opportunity to see everyone before the end of the year. We are extremely excited for this webinar sponsored and supported by JA Solar and TÜV Nord, where we are going to discuss something extremely important. We are going to mix what is good for next year, what about new innovations, and we are going to focus specifically on our region, where we have extra challenges in terms of temperature, humidity, and so on, which are the two worst enemies of solar modules. I'm very happy and excited to be accompanied by a great professionals. I'm going to start with ladies first, as usual. We have Aseel AlSa'adi, the technical manager from JA Solar. Aseel is, number one, is a dear friend that I am extremely proud of. And since tomorrow Jordan plays the final, Aseel, we have to also wish you a very good luck in the game, you, Dr. Ashraf, and myself. Hopefully we get a good result. We also have Mr. Shimeng from TÜV, and it is extremely important to talk to companies like TÜV that provide a lot of stability for such new technologies. We have a big discussion and a presentation coming up. We have Dr. Ashraf. Doctor, we are very excited to have you with us. Inshallah, the first of many more, bi'idhnillah ta'ala, in the upcoming stage. And we are going to be joined by also my friend who likes to make an entrance always, Ahmed Ziada, who is a little bit late. But today we are going to focus on new technical innovations that we feel are extremely important in this part of the world. And we are going to explore how solar module suppliers are adapting to overcome such challenges, specifically in climates that are extremely challenging. And we know that this region is also growing fast by the day, so it's becoming more and more of an importance. So before we start with this webinar, I don't want to take a lot of time. We want just people to join in, to catch up. But before we go, I just want to remind one very important thing. Please tell us about yourselves in the chat. We would like to build some sort of a community. If you would like to share your LinkedIn pages, please do. Introduce yourselves, what you do. Maybe we will be able to all communicate together. And I just want to make sure that please keep on writing your questions in the Q&A section, and make sure that you write them directly, because sometimes people forget. I sometimes think of a question and I forget about it at the end. So we are going to go at the end of the session and answer most of the questions according to how much time we have. In order to catch up and make sure everybody joins, inshallah, I just want to ask you one question. So we're going to start with a poll in order to know where are you from, Shada? So let's see, Saudi, the rest of the GCC region, UAE, Bahrain, Oman, Qatar, Kuwait, Jordan, Palestine, Syria, Lebanon, Iraq, Egypt, Yemen, Sudan, Libya, Tunisia, Algeria, Morocco, or others. Of course, since the presentation is going to be done in English, so it's going to give us a very good exposure on markets outside as well. We see we have most of our attendees from Syria, Lebanon, Iraq, which makes sense regarding the market movement in these markets. Saudi, we have a decent amount. The GCC, of course, it's a very important topic for the GCC since it has the most challenging circumstances in terms of weather circumstances. I'm not going to take a lot of time. We have a very busy schedule. So Aseel, if you can please share your presentation, share your screen, and go ahead. We are going to turn off our cameras to make sure everybody has the best exposure in terms of screen.
Yes, Waleed, I'm sharing my screen right now.
100%. It's perfect. You can proceed.
First of all, thank you for panelists and thank you for everyone joining today's webinar. I'm Aseel AlSa'adi. I'm Technical Manager of JA Solar Middle East and Central Asia. And today we are going to discuss JA Solar Innovation 2026 with a special focus on Desert Blue and DeepBlue 5. Let's move on. We will discuss several key pillars, starting from the technologies, then reliability and system value. So first of all, I would like to give you overview about JA Solar. JA Solar is a globally trusted PV manufacturers with a strong presence in the world and proven reliability and also long-term bankability. It's founded in 2005 and listed in Shenzhen Stock Exchange with 317 gigawatt of cumulative shipments as of Q3 2025, reaching 180 countries. And market share of JA Solar is around 14.5%. And we have more than 2,000 patents as of Q1 2025. We also recognized and listed for multiple consecutive years in Fortune China 500 and in Global Top 500 in New Energy Enterprises. And JA Solar is top tier brand, top tier bankable brand. That's just overview about JA Solar. Let's move to the technical part. So first, we will discuss the first module, which is the next generation DeepBlue 5, and then we will go to the next one, which is Desert Blue module. So first, regarding the first module that we will introduce in next year in 2026, it's DeepBlue 5 module. So this product integrates JA Solar advanced Lithium 5 cell technology with higher power, superior reliability, and lower levelized cost of electricity. And every feature mentioned on this slide will be discussed in detail in the following slides. So this product, DeepBlue 5, enhances the aspect of optical and electrical performance, starting from wafers to cells into the modules. So in order to boost the efficiency of our module, we have to work on those three key pillars. Starting from the wafers, we are using premium wafers, more concentrated resistivity and improved uniformity. And we also are using Lithium 5 cells technology with high efficiency anti-passivated contact cell technology, with optimized structure for enhanced light absorption and defect compensation to reduce recombination losses with ultra high open circuit voltage up to 749 millivolt. And we go beyond improving the wafer and the cells to continuously improve the module design itself. So we included and incorporated several features in this DeepBlue 5 module, such as high density packaging, ultra transparent material, and composite structure enhancement to make consistent enhancements of the layers used in the PV module, and we are also using multi-shared cut. This product offers power from 650 up to 670 watt with efficiency of 24.8%, and the bifaciality is boosted to have 85%, with temperature coefficient up to minus 0.26%, and it's also improved compared to the standard module. And the annual degradation of this product is 0.35% compared and it's improved compared to the standard module. Sorry. Let's talk about the technology used in this product. DeepBlue 5 integrates several technologies. The first one, we are applying 20 multi-bus bar and also back polyfinger. So using 20 multi-bus bar will help us to have shorter distance for the current, and this will lower the resistance up to 30%. This will help us to have lower heat losses and higher power generation directly. And regarding back polyfingers, as you can see here from this photo, that we are applying local. As you can see here, we are applying a local thin polysilicon to let more light through the front side, from the back side through the front side, in order to generate more power. And this will help us to boost the bifaciality up to 5% and the cell efficiency up to 0.2%. Other technologies incorporated and engineered in this product gapless flexible interconnection, and anti-dust frame. Regarding the gapless flexible interconnection, traditionally solar modules have gaps between cells, like we have inactive areas between cell to the next one. But in the standard modules, it was like 1.5 millimeter. And then in DeepBlue 4 Pro, the current modules that we are using now, it's improved and reduced to 0.5 up to 0.7 millimeter. But in DeepBlue 5, which is the next generation module that we are discussing right now, we are applying gapless flexible technology, and it's GA Solar patented solution. So it goes one step further because cells are overlapped, creating a negative gap with no inactive space. And this will increase the utilization per string of cells up to 15 millimeter. So we will have full appearance of the module and we can collect more light. So directly we can boost the power generation of this product. And also we are applying a film buffer is applied to the overlapping area to prevent any micro cracks. So we also looked into the reliability of these overlapping connections to make sure that there are no micro cracks in between. And we are incorporating anti-dust frame in DeepBlue 5 model. So the short edges of A and B sides have holes which can increase the speed of rainwater flush or runoff under vertical installation. Like if we have dust, it can be flushed directly once we have rain fall or once we have any water cleaning through those gaps or holes circulated and distributed on the short side of the frame. So this sheet or this slide shows comparison between DeepBlue 5. So DeepBlue 5 improves on DeepBlue 4 Pro in terms of power, bifaciality, temperature coefficient, and also linear degradation. Furthermore, we also apply a multi-cut design for DeepBlue 5. And the appearance would be full screen, which we discussed earlier in the earlier slide. So if we need to summarize the overall performance of this product, the overall power generation over the entire life cycle of this product can be increased by approximately 2.5% because we will have lower degradation and we will have higher bifaciality factor, better temperature coefficient up to minus 0.26% per Celsius degree, and better low light performance. So we can generate power even during mornings, evenings, and cloudy or rainy days because we are having full screen and TopCon technology that will help us to boost the overall generation. So let's take a look into the next product, which is Desert Blue. It's a specialized solution for desert environment. So as you know, that desert environments have some challenges like dust accumulation, sand abrasion, a strong wind, and extreme heat. So in order to overcome these challenges, GA Solar launched a new product that can be installed for this environment for desert, only allocated for desert environment to overcome all these challenges that we have in deserts. So because these conditions, as you know, can increase soiling, can increase also mechanical stresses, provide or makes the module susceptible to thermal losses. So these conditions require a desert optimized module design, and that's why GA Solar launched the Desert Blue product. So Desert Blue product is a specialized solution for desert environment. So what are the advantages of Desert Blue module? We offer quadruple advantages. First, that we kept the dimension of this product up to 2382 by 1134. It's the same dimension of our mainstream products that are available in the market, but the power of this product can reach up to 650 with efficiency of 24%. So we kept the dimensions the same, but we improved the characteristics and the features of this product to be installed in desert environments. So the breakthrough technology of this product that we are applying a nano-scale coating layer, which will help to minimize dust adhesion and improve module light transmission rate, so we'll have higher energy yield. And also this layer is abrasion resistant, and this product is can withstand higher loading with better temperature coefficient up to minus 0.28% per Celsius degree. So I would like to show you this video. This video compares a regular module with the Desert Blue product. As you can see, the Desert Blue can resist dust accumulation, while regular module can attract dust to the surface of the module. So in this slide, we show you and we compare Desert Blue module with standard module. So while both offer the same power range and bifaciality factor, but Desert Blue module delivers better temperature performance, reduced dust adhesion, and lower cleaning needs, up to 50% operation and maintenance cost lower or reduction, so resulting in a higher long-term energy yield. Let's talk about reliability of Desert Blue module. In this presentation, we will focus on reliability of and durability of a Desert Blue module and not DeepBlue 5 because we are short on time. So we are focusing on Desert Blue module reliability. So we have tested Desert Blue modules under glass light transmission decay and coating hardness tests. So because Desert Blue modules are engineered for superior reliability through advanced coating layer. So in order to test the coating layer used, we have to test the modules under glass light transmission decay and coating hardness. So what are these tests? These tests are used to evaluate and verify stable transmission performance of the modules after dust and sand exposure in dusty environments. So as you can see from chart 1, the glass light transmission decay, the Desert Blue modules have better performance in terms of light transmission decay and offer better coating hardness compared to standard modules. So this will extend the coating layer up to 3 to 5 years compared to standard modules because we are applying a nanoscale coating layer on the Desert Blue module. So this layer can withstand harsh conditions in the deserts and extend its lifespan up to 3 to 5 years. So in this key pillar, we will discuss system level and product level impact by TÜV Nord. So JA Solar collaborated with TÜV Nord to test the modules under different test sequences. So, and we launched a white paper. So this white paper goes deeper into desert-specific stress factors, and TÜV Nord validated that Desert Blue's design and materials can withstand harsh sand, heat, and dust conditions, so giving clients long-term values for their projects. What are these tests? Let's move on to the next slide. There are several tests are validated by TÜV Nord. These are a couple of charts. I summarize them from the white paper. But I highly recommend you to read the white paper because the white paper tested the modules under different test sequences, and we have showed the results. So confirming that Desert Blue module can withstand dusty and sand environments in deserts. So the first test, sand dust abrasion resistance performance test, and the modules have undergone these tests, and the results show degradation less than 1%. And we also applied and exposed the modules under high UV aging tests, more than 220 kilowatt hour per meter square exposed to the modules, exceeding and far beyond IEC standards. And we have obtained the results. The results showed that the degradation is less than 2.5% under extreme UV radiation. Subsequent sandfall test also caused degradation of 0.09% for the modules, and other tests also validated, such as combined thermal shock with UV aging and combined high temperature with thermal resistance, also combined high temperature with static mechanical load and dynamics mechanical load of the modules, and then all the results showed published in this white paper. So we highly recommend you to go through this white paper to make sure from that you have full information and the results and the values of each test highlighted in this white paper. So to summarize this white paper, first, the core performance improvement of this product, the temperature coefficient of Desert Blue module is minus 0.28% per Celsius degree. And because we minimize the dust accumulation on the surface of VV modules, so it operates 5 Celsius cooler compared to standard modules. And we have applied multiple reliability testing in collaboration with TÜV Nord, as we mentioned earlier. We also have higher product performance, which means that reduced power loss under dusty conditions up to 14% compared to standard modules due to using self-cleaning nano coating, which provides great advantages of BV modules to reduce dust adhesion and eventually provides higher long-term performance ratio. In terms of customer value, we reduced the CapEx and OpEx by applying this nano coating layer, because these modules do not require frequent cleaning. That's why reduced CapEx and OpEx eventually, and we cut around 50% of operation and maintenance cost. And if we need to talk about energy yield boost, we have also validated 2 projects by testing them outside in real performance, and we have obtained the results in collaboration with TÜV Nord. Let's see them in the following slide. Okay, under heavy dust conditions and real desert environments, we compared Desert Blue module with standard modules in Fengshan GA Solar Factory, and the results delivering 7% higher power generation. And we also installed another project in another area called Ulan Bu Desert in Inner Mongolia. Under heavy dusty conditions and real desert conditions, the modules of Desert Blue delivered up to 5% additional power generation. And that's all from my side regarding the latest GA Solar products. So that's all, Waleed.
Shukran, Aseel. It's really, really brilliant. And I'm actually also a little bit excited about the DeepBlue 5. I have just a very quick question for you, Aseel. Is there going to be a Desert Blue product using the new advancements of DeepBlue 5 cells?
That's early to answer this question, but I believe yes, because the Desert Blue module is providing features of the modules, because we are adding self-coating technology layer on the BV model. So we can incorporate this feature into DeepBlue 5 once we release this product next year.
Brilliant. And is there a timeline for the release for the DeepBlue 5? Is it available now, or is it going to be available next year?
Yeah, by next year. The availability of DeepBlue 5 by next year, inshallah.
Inshallah. Thank you very much, Aseel. It's brilliant. Really very, very, very good product to have a look at. I'm going to definitely be waiting for the documents to do my tests as well. Shukran. So we're going to switch to Mr. Shimeng. And speaking of this white paper and the results that came, which, by the way, our colleague Shada, who we all thank very much for her support, has shared the white paper on the chat. She's going to share it a couple more times for people all to install it, download it, and maybe have a look at it. But it's extremely important to know that such white papers, especially if it's supported by a big corporates that do third-party testing certifications, such as TÜV, are extremely important. So we're going to hear a little bit from TÜV. Shimeng is going to help us a little bit about this white paper, this test, and such tests in this region, the importance of them, and then we can start with our conversation. Please, Shimeng.
Hi.
We
Hello,
can
everyone.
hear you and we can see the screen. You can proceed, Habib.
Okay, great. Hello, everyone. Thanks for the invitation and thanks for joining the event. So my name is Shimeng Wei from TÜV Nord. I'm the Vice President in Business Field Renewables and responsible for testing, inspection, and certification of the PV products and energy storage systems. So me personally have been in the PV industry roughly 50 years, and I am always working in the quality assurance areas. So we see the development of the industry, it gets ups and downs all the time. And I'm always feel still amazed about the real rapid changes in technologies. So really be excited about the new changes and also the emerging technologies. Where for this time we want to share the topic together with Jay about the evaluation of the PV modules for the application in the desert. So we know that for different scenarios, different applications in the desert, in the offshore, we need different products to fit into the environment. Therefore, in this specified application desert, where we see different challenges of the PV modules for that application. And mainly there are three factors that we need to consider. One is the high dosage of the UV irradiance, which will cause the UV-induced degradation for solar cells. It has accelerated aging for encapsulant materials because they are plastic, and also has the accelerated aging for the junction boxes, which also has is kind of the plastic products. And then we have the factor for high temperature in the desert area, where we have a big power loss, where the temperature is higher and the power is lower. The modules would also suffer when it has the hotspot scenarios. The hotspot endurance will be more severe than the normal the other areas. And due to the fact that there are significant differences in the temperature between the daytime and nighttime, the impact of the temperature to the modules could cause the electrical connections reliability to be reduced. Last but not least, we have also the very high mechanical impact by the sandstorm in the desert area, which causing the aberration, some unexpected shading, and also the mechanical integrity, not only to the modules, but also to all the components like mounting brackets or trackers or everything. So in that sense, TÜV Nord develop a test program based mainly 6 aspects to evaluate the modules for the application. Cluster A is about the high UV accelerated aging. Cluster B is for the combined aging with high and low temperature shock, which is representing the big temperature differences in the desert, but it's also combined with the UV. The third cluster is the high temperature resist performance, which we check not only the hotspot endurance test, but also all the functionals of the bypass diode if it can survive the elevated temperature environment. We also have the mechanical load performance, but tested or evaluated under high temperature to see if they can if this can also survive in such environment. We also have the sand and dust aberration resistant performance to check the aberration resistance for the glass and also the coating. And last but not least, we also have the outdoor performance test to check the performance, like the real performance actual power generations. Some details of the test. The high UV accelerated test agent, we make the UV radiation accelerated test under 60 degree of the ambient temperature, and the total amount of the UV dosage is 220 kilowatt hours per square meter, which is at least over 10 times of the requirement in the IEC standard. So this is something that we can see if the encapsulant materials or others is fitting into such environment. The second cluster, we have this combined aging test. In the conventional IEC standard, we have the high and low temperature cycling test, which is from -40 degrees to 85 degrees as one cycle. And but we also changed the duration of the high and low temperature stages respectively to 12 hours and 4 hours, so it can relatively represent the desert environment. And meanwhile, when the sample temperature is above 0 degree, which means the sun is start to rise, and therefore the UV light will start to impact on the modules. We induced also one UV light exposure under 180 watt per square meter, and the accumulated UV irradiance dosage is 60 kilowatt hours per square meter. So with these two combined factors, we can accelerate the testing and to see if the modules can survive under such comprehensive stress. The third cluster is the high temperature resistant performance, where we do the testing for the hotspot test, but we increase the irradiance level to 1,300 watt per square meter, and we test the module under the ambient temperature at 80 degree, and to evaluate verified performance during this hotspot endurance test. Sometimes we see for such scenarios, the temperature of the solar cell could be up to even 200 degrees, and it could causing a lot of problems, especially fire hazard for the modules installed. We also have the bypass diode thermal test and thermal runaway test to verify the diode performances. And then we have the high temperature mechanical load performance test. In conventional IEC standards, we have all the three tests: the thermal, the dynamic mechanical load test, the static mechanical load test, and also the non-uniform load bearing test. But they are all tested in the room temperature, which is not really happens in the real world. Just for example, the snow load defined IEC standard is also tested at the 25 degree environment ambient temperature. So, but when we have a real snow load, the ambient temperature will not be like 25 degree anyway. And so we need to adapt the testing to the real environment. We also adapt and increase the load bearing during our testing, where that to represent the higher sandstorm, for example, the sandstorm in the field. We also have the operation test, which follows the different IEC standards, and also we made one specified test to combine the sand blowing and robot cleaning, which is also very common when we do the cleaning in the field using the robot. There will also be some sand blowing. You cannot really control the environment, and also we simulate the robot cleaning at the for 11,000 times to simulate typical periodic impact of the cleaning of modules over 30 years. Last but not least, we have the outdoor performance test, where to collect and verify the actual power generation compared to the simulation and others, according to the IEC TS 61724-2 standard. So as introduced, that different applications would need different evaluation and could have different evaluation methods. So to not have developed certification scheme for different applications, like the current desert Gobi wasteland application, but we also have like high altitude application, the high damp heat area application, extreme coldness application, and also offshore applications. So with different schemes to evaluate the performance of certain applications, we could see which module could fit into such environment, and also what would be the best for considering of the LCOE and your return of your investment. And that is all. Thank you very much. And I give the floor back to the coordinator.
Thank you, Shimeng. It's not easy, I can believe, with the speed of the development for the modules and even inverters. We see them moving very quickly, trackers as well, robots as well. I'm pretty sure it's not easy to maintain your responsibility as a third-party testing company to actually make sure that all these new technologies can provide the value they promise.
Yes, yes and no. So when it is hard to evaluate because we cannot really put the module to 30 years, let's say, to really evaluate the real performance. We always need to do the accelerated testing, for example, with higher temperature than real and lower temperature than reality. But the problem is we cannot also overdo it, because let's say where you have an egg, and you make a certain temperature to raise it, then you get a chicken. But when you put it too high temperature, you got a boiled egg. So we have to carefully select the test severity, and so in order not to overdo the test. That's where the hardest thing is.
Thank you, Shimeng. We have a couple of questions to talk about that afterwards. I would like for everyone, please, to open their cameras as we will go into our open discussion. Until we give Aseel and Shimeng a chance to catch their breath, I would like to ask you a question regarding what kind of business background you come from. Are you developers, EPCs, investors, public sector, academia, consultants? This will help us diverge our discussion into a more productive discussion for everybody watching. Ahmed, Dr. Ashraf, are you able to open your cameras as well? Ahmed, you're out. Okay, mashallah.
Yeah, Habib?
You are outdoor, بقول.
Yeah, I'm really sorry. I'm still in a meeting. But of course, joining you guys is really a great privilege to be among all these stars in the industry. So thanks so much for having me here. I'm really sorry I came a little bit late, but
okay,
hopefully that we will not miss anything. Thank you.
Thank you very much. Thank you. We will actually go to you, Ahmed. We will start with you, because the discussion here, we are talking about a new technology with an amazing innovation that can have a massive impact on the region that you work in, Middle East, North Africa, Sub-Saharan Africa, all these areas with the challenges there. And then we have the ideas that TÜV bring in to try to support developers like yourself in order to make sure that these technologies satisfy what you want. Can you tell us a little bit about the importance of reliability and the impact they have over the lifetime of your projects when you offer 20, 25, 30 years PPA sometimes?
Yeah, this is something that it's a basic now. You know, before I was working in as a technical manager, and I spent my life was a technical guy. So for me, reliability was most like to be in a technical aspect. But once I joined to be a developer, it's more to the financial, not to the more than the technical part. Once we talk about reliability, we'll talk about the first year LID, LETID, and we are talking about the degradation over the years, because every single change in the degradation, this one worth money for me. So for us to make sure that we have reliable, we say this is module is reliable, it has to be converted to money for us. So that's why we go we use some terminologies for the reliabilities, definitely like as I said, that like degradation and how the performance of the modules over the years, because a slight change in any one of these aspects will cost a lot in our discussions and in our costing sheet. Not also from our side, also from the lender's perspective, because at the end of the day, you have to convert all the technical discussions, all the terminologies that shows the bankability and the reliability of the company like GA here. It has to be converted to amount of money. This is what we are definitely doing
point,
over
Ahmed,
our
I think. Because it's not always only your decision, it's also the lender's decision. And the lenders, of course, use the feedback of companies like TUV to make sure that what we are doing. So do you feel it's not easy to apply new advanced technology in big projects regarding bankability, or reports like the white paper we are discussing today can help with that?
I will be frankly with you. I will be very frankly with you. Once we talk about utility projects, once we talk about gigawatt project or more than that, we talk about hundreds of millions here. So that's why the lenders became more cautious, developers became more cautious when they take such a decision. So for us to have only to make my decision based on a white paper, most likely it's not that like, okay, I have to give it as a priority. For me, priority to go for more bankable, reliable, certified, approved product and technology. But in the same time, also, there is something that is also I would love to highlight here. That is, most of the developers now became more aggressive, became more futuristic. So I think as Mr. Wee explained, and also Aseel explained in their amazing presentations, that we have to make balance between conservative as a lender or a developer in going for a new same time, be futuristic and to get to innovations. So this is that I'm telling you very frankly that this is the challenge that we are facing now, because when I build my financial model, I have to make sure that this is financial model, this product is solid for upcoming 25 years. I don't want to renewing my plant after 5 years or 10 years. I remember Dr. Ashraf, he discussed something about renewing the modules, and some of the plants now are over 10 years and it's now even in the renewing phase. So I want to make sure that in my renewing phase, it will not after 10 years, it will be after 15 years, 20 years, something like this one, to make sure that I am ahead of the whole market. So it's not an easy decision at all, honestly speaking. And there is so many financial models, so many works that we are doing based on this one. And reliability is one of the key factors. But again, reliability, we cannot say it as a name or a very nice word, but we have to convert it in money so we can measure it. If you cannot measure it, you cannot succeed on it.
Shukran. Thank you, Ahmed. Thank you very much for the feedback. A very important point. I will go back to Aseel about it after a little bit. But building on the reliability, I'm going to go to Dr. Ashraf. Doctor, now with the increased focus on reliability of solar modules as a component, reflecting, of course, the reliability of the entire solar power plants. How important, in your point of view, because I have discussed with you earlier a little bit about the reliability of grids and the challenge that we have in the grids in this region, how do you feel that improves the reliability of solar power plants, which improve the reliability of national and international grids in the same way?
Yeah, thank you, and good day for everyone. And I would like to thank you for organizing this meeting. And I would like to thank Aseel for her presentation, and Shimeng also. And I would like to tell her that I'm in love with the DeepBlue 5. So it's I wish when I was like the head of the tenders committees and in some entities to see this technology, and I see it has really good, promising future for that. Regarding to the reliability, actually there are two sides for the reliability. One side started from building the farms, And with building the farms, and I wish we can see from GA Solar and the providers companies to have a real data, not simulated data, so they can build like some farms uh, based on this technology and see the input sizing. Because we had really a problem before. For example, one of the project that I used to be the manager and the project manager for them. So imagine the capacity and the sizing that they need, the company or the entity. I don't like to mention the name. They said like we need 7 megawatts project or farm. So when they input the data and the sizing to the grid company or the national company, they said you have to build 9 megawatts in order to comply the reliability. And this is really what we need. If we can take a recommendation after this meeting, really to have a decision for the reliability, for the input sizing. Sometimes they don't give really the true inputs for the GIS companies who's doing the grid impact study. They give like different inputs. So at the end, they ask you to build a solar farm with bigger capacity. That's exactly what happened. So they give to the company who did the GIS with different inputs. At the end, the provider, and especially with the one who is building the farm as a POT, they, instead of building 7 megawatts, they build 9 megawatts with like 28% increments in the size, which really cost a lot for this company. And regarding to the other side of the reliability, when we talk about the grid interconnection between the countries, and especially when we talk about the extra connection between Syria, Jordan, and Egypt, and when we notice now after Caesar Act, the sanction that's now removed from United States, I think we can increase the reliability by this interconnection, and we can support the decision makers to go and push in this side or in this direction to increase the reliability. And by the way, regarding to this, I was like committee member in the fact finding in 2021 for the blackouts with NIPCO, and we were discussing the reliability with the we really so that we had really problem with the data that they are giving. They are saying, oh, the renewable energy, the PV systems, they are representing now 60%, and we can't control that. And we have really a problem. This is one of the causes, but we don't know what's the problem is. I think the providers, the innovators from the like JA and other companies, they are providing and building the solar modules. They are doing their job very well, and we see the innovation. We see the really great job they are doing, and I'm really happy and surprised about the technology that they are doing with JA, and I would recommend their job, their work. And yeah, regarding to this, I was like preparing some slides regarding the reliability and the input sizing and how we can read the other side of the solar farm and the integrating of PV systems to the network, to the grid, so we can complementing each other. So yeah, for that side, we need to go through the reliability through the interconnection between the countries. This is the first one, or the first important factor. The other thing, we need really to put a what we call it transmission code. We need to put input code and make transparency about that, so it will be fair for everyone, the provider, the one who is really need to build the the solar farms.
Shukran. Thank you, Doctor. Thank you. Very, very important topic, especially when we talk about a region like ours, where we have a lot of markets around us that have a very unstable grid. So definitely, we will go back to the product side now. And I have a very question that I have seen more than one place. So Aseel, nano coating has been a thing for a while, and most of the challenges used to be because the lifetime of nano coating is usually shorter than the lifetime of the module. So how do you feel that such coating for desert technologies can be sustainable for long term for your product? And do you suggest any sort of maintenance after 10, 15, I don't know, certain time to make sure that the coating is still working at the highest quality?
Well, that's a good question. Actually, this coating is a layer, so it's integral part. It's durable. It does not require repair or so, and it's tested already to withstand lifetime. So it's layer. It's not only coating, and it's integral. Those parameters are so important to know. So it does not require any repair.
Brilliant, brilliant. Because there is a lot of companies who sell the coating separately, and
That's
this is
different.
completely
That's
different.
different. Yeah.
Yeah. Thank you. This is a very, very important note. And there is a lot of questions about your new technologies. I think everybody is extremely excited about the DeepBlue 5, that they are already thinking about what is going to be next. Shimeng, I have a question for you, especially now with these additional coating layers. And with the increased use of robotic cleaning systems, how can also new tests help with making sure that such cleaning systems does not affect the layers that the module suppliers are using in order to make sure that the technical advantages come for long time?
Yes, so from the testing perspective, actually from IEC, we have the standard called IEC 62788-7-3, which is also indicating in my presentation, where they could simulate the aberration of the PV module for this coating, specified coating part. So we can do the testing and simulation for that. Usually we have a scheduled cleaning in the field from our operation and maintenance team. And therefore you could calculate actually how long that, how many cycles the robot will do during the lifetime of the modules. And you can just simulate by that. And in that sense that you don't really have to wait for that long time. It's very fast to do the simulation on that. On the other end, the coating itself, it's not only that related to the manufacturers or from manufacturers. The coating durability is also affected by the level of operation and maintenance team, where they could choose a suitable robot, and depending on the area, what will be the cleaning schedule, how to do the maintenance schedule for this, and with some optimized maintenance of the plant, you could also prolong the coating lifetime, actually.
Thank you. I see also a question to Aseel. I'm going to go back to Aseel. Aseel, now you are changing a little bit the structure even of the cells inside the module, and of course that comes always with a mechanical risk. Can you tell us a little bit about if there is any change in the glass, because you talked about the changes in the cells themselves, but changing such technologies mechanically, is there any tests or improvements that you have done to make sure that the new product can provide the same quality in terms of mechanical resistivity?
You're discussing about DeepBlue 5 because the design of this product is different, right?
Yeah. The question talks about DeepBlue 5.
Okay, actually, we acknowledge the renowned lab's results and observations regarding glass breakage and regarding the glass quality and mechanical load. So at JA Solar, we use enhanced glass strength, and we do optimization between the frame and the glass to make sure from thermal expansion, because every material has thermal expansion to contract and to expand during temperature. So we optimize these parameters, and we also do strict supplier control for incoming the glass. And regarding DeepBlue 5, the slots that we use to install junction boxes are different, so are circulated in different places. So before, in the current module, we have 3 slots concentrated in the middle of the glass, but in the new model, the slots are circulated in different positions, which will make the module more stable and reduce the stresses on the glass. So the engineering behind this product is different, and it's improved compared to standard modules.
But it doesn't use a new kind of glass or a different technology.
For DeepBlue 5, no, but we improved the integrity of the slots that are available on the backside. We circulated them in different locations rather than to be circulated in one position or in the middle of the module. So that's why it will provide more integrity and reduce thermal stresses and mechanical stresses of the glass itself.
All right. I have a question here. That's a very good question about the Desert Blue product. You changed something in the frame of the module in order to help with the extraction of water, as you mentioned earlier. Does that apply for both monofacial and bifacial modules? That's the first part of the question. And the second part, does it require any special change from the mounting structure or the tracker supplier, or it's the same as standard?
Okay, also that's a good question, because in this presentation we discussed 2 models, Desert Blue and DeepBlue 5. For DeepBlue 5, it's incorporated with anti-dust holes. So you can ask for them, and if you don't need them, you can ask that you don't need them, because these slots are good for installations that have rainwater or that have more water to flush or run off the dust with the water moving. So if you don't need them and you need to install the modules, like for example, in dusty and sand environments, and you don't have water, then you don't need those slots. So the slots can be optional for a DeepBlue 5.
But they are a brilliant idea. I love them.
Yeah, it's JA Solar patented solution as well.
It applies for monofacial and bifacial, right? Or it's only for monofacial?
In JA Solar, we focus on bifacial. Once we shifted our production to TOPCon technology in 2022, we consistently focused on bifacial. We have monofacial for small size module that's used for residential scale, but applying anti-dust solution applicable for the mainstream products, which are the bifacial ones, because we are focusing on bifacial, obviously not monofacial.
Understood. Thank you. Shukran, Aseel. Shukran. I'm going to go to Dr. Ashraf in a quick question. Since you are speaking about utilities, grids, interconnection possibilities, a couple of people here asked also part of the reliability and the growth that this industry is doing. It is going to have a little bit of an impact overall after some time when it comes to grids requiring to reinstall or change the module types and so on and so on. Anything you have evaluated before that talks about the recycling of these modules? And since, of course, there is always new technologies, maybe some of them will be easier or harder to recycle than the others. Have you evaluated such a task, such a topic? You are muted, Doctor.
Yes, actually, I was a referee or a judge for some project for that regarding some defects for really huge projects, and that's why when Shimeng talked about TÜV, that's really the testing in general is really important in order to avoid having really a massive number of modules they are not complying the important test. At the beginning, in all the countries, and that's now what's happening in Syria, and that's what we are warning the people in Syria. Please comply the test. Ask the people for the one who's doing the test, like TÜV, to check the test, the modules, to avoid the recycling later, because a lot of countries who's really were crazy about the technology of the solar farms or solar technology. They were importing a lot of solar modules not complying the criteria, and after maybe a couple years, just only most of the farms went out of the service. That's why when we talk about really credential and really famous and high quality modules with going with the testings and passing the testing regarding the TÜV or any other testing companies is really important. This is to avoid the recycling as much as you can and as early as possible, because we saw, and I really faced some projects after 2 years they needed to change like really a huge number of modules in their farm.
Yeah, and I always, when I discuss this with, I tell them, if you look at the biggest developers in the world who provide the lowest prices, the lowest tariffs, they use the top module suppliers, and of course, these people really understand what they're doing. If going for a cheaper module is going to help the project, they would have done it. But no, still they go for a very, very reliable products, as you just mentioned. Shukran, Doctor. I'm going to just push for a couple of minutes because I have two final questions for Aseel and Shimeng, and then we can conclude. The first, I'm going to go to Shimeng. Shimeng, it's a very good question, actually. Based on your perspective from a testing company, where do you feel that the industry is most critically at? So which aspects of the tests you feel are very critical, specifically for in the accelerated test, of course, for markets like ours? Because there is a lot of questions here about the mechanical. Apparently, some people are having some problems in that aspect with the change of sizes, cell size, and so on. Please.
Yes. So we should understand that the standard is always behind the real world, which means that when we have some issues found in the real world or in our real plants, there will be like follow-up discussion, and then some new standard will come to see how to do the evaluation, how to do the testing, and to make sure that the modules has such aspect is secured. But in that sense, we see some, when the new technology comes, sometimes we see some problems already, but the standard is really behind that. Just for example, we have the UV-induced degradation for PV cells, which is have a highly discussion these years. We also have nowadays some PID issues with the NPID and PPID, the different scenarios. And in that case, the standards are still in the working stage, which the experts, we are, to be honest, a part of the writers for the IEC standards. So we are the IEC standards are still in the working stage, but we are also trying to expedite on that part. On the other end, some standards or some tests are not really fitting to the real world. As I just mentioned, for the mechanical load, especially the snow load, it only says to test under 25 degrees, but this is not real, because the snow cannot survive at 25 degrees. So for different scenarios, we need to also accordingly to make test plans accordingly and to fit into the real world. Another example is that I believe lots of plants nowadays are suffering from the backside glass breakage, which we also hear a lot, because infringement of the modules and some different treatment of the glasses, for example, but also sometimes it's the external forces, not from module quality itself. So a lot of things a lot of measures need to be taken, not only from the module side, but also from the operational maintenance, also from the design of the mounting bracket to support the modules, because modules are not alone in the air. It's always put on the mounting brackets. And so all the factors must be considered altogether. And when we do the evaluations, when we have real plant projects to do the design, it's also good to have some expert opinions where we could also provide some support in that sense to make sure that even with emerging technologies, we can always be on the safer side for these projects.
Thank you, Shimeng, very much. It's extremely important. You don't understand the importance of these things unless you start really working on the long-term lifetime of these modules. Aseel, we're gonna end this beautiful webinar with you. As a technical person from a technical background, to be honest, I am dazzled by the 5 new product. Of course, the Desert Blue as well looks very, very promising when we talk about real desert areas. So as a technical person, giving an advice to the audience when they come to choosing the right modules for their installation, how do you suggest they approach this topic? How can they evaluate in between the DeepBlue or Desert Blue? Just an advice from a technical perspective in terms of the selection of the right technology.
Thank you also for this webinar, and thank you for all the panelists for their thoughtful contribution to this webinar as well. So at JA Solar, we provide diverse solutions because we understand that not every environment behaves the same. So we have to provide diverse solutions for deserts, for high altitude environments, for cold environments, for agriculture's environments. That's why those solutions can overcome the challenges on each environment. So maybe approaching us to provide you with and to propose you with a proper solution, because I tried to squeeze the presentation into a couple of slides, but we have to add more information about those 2 products. I'm afraid that I confused some of attendees about the features of each product, so that's why approaching us would be very helpful to give you more insights and more information about each product, and follow us on LinkedIn to know the features of each product as well, because we cannot provide every information in 15 minutes. So sorry for that.
Yeah, well noted. What's beautiful is that Aseel is very accessible. She's helpful, she's supportive. So if anybody, you can approach her. And if Shada, if you can also, she just did, mashallah. Shada just shared Aseel's email address on the chat. And of course, Mr. Barry, who also works at JA, providing support for the region. Approach them, ask them about what's the right technology. Unfortunately, the market now does not look into these small details, but believe me, it plays massive role in the success of your power plant and your investment. I apologize for the 8-minute delay, but it was too good to stop. Thank you, Aseel. Thank you, Shimeng. Thank you, Dr. Ashraf. Thank you, Ahmed, who had to leave us already. And we will definitely stay in touch for upcoming webinars to discuss more and more about how technology can help such industry to always optimize and become as reliable as possible.